Hello YouTube, on this side. So today's video is also continuation part of KEDA tool, with aka Kubernetes Event Driven Autoscaler. So in this video, we will be talking about how we can use Prometheus metrics to autoscale our pods of the application. So as you already know that KEDA provides various flavors and various type of scalars which we can use to autoscale our application in our Kubernetes cluster. So in the screen, as you can see that this is a list of scalars which KEDA supports to autoscale the applications. So one of the scalar is Prometheus. So in my first video, I have already spoken about the architecture of KEDA and how the internal thing work to autoscale the pods. Even I have also used one of the scalar which is cron to autoscale the application. I will be posting the link of the video in the description itself, and I will be adding the card itself so that you can also go and check out that video. Because in this video, I won't be explaining you the architecture again and how the internal things work. So I think you all already know that Prometheus is an open source tool which is used for logging and monitoring with Grafana. So, if you don't know, so let me just give you a small intro about Prometheus. So, Prometheus is uh, time database. So Prometheus display or store the logs and the metrics of the application in time data series, so that within the specific timestamp we can check the log of the application, and if we want to visualize how the things are working and how the nodes and all other resources inside Kubernetes clusters are working, then we can use Grafana. So Prometheus and Grafana is a famous tool, famous pair of tools, which is used by many projects and many companies. So let's not uh, uh, waste more time on just description and introduction of Prometheus. So let us understand how KEDA use Prometheus metrics to autoscale the application. So this is the official website and documentation site of KEDA. So in this page, we can see Prometheus, which is scale application based on Prometheus. And this is the code section or the YAML section, which we can integrate inside scaled object file, so that we can target the specific deployment or service which we want to autoscale. And in the trigger section, we have mentioned type should be Prometheus, and in the metadata, which is required section for this, we are just mentioning the server address where the is Prometheus server is working. So this is the URL of that, and 9090 is the default port of Prometheus. In the metric name, have just given the name of the metric, and in the threshold, this is 100. So 100 threshold here means is if this metric is crossing the value of 100, then it should be triggered by the KEDA and autoscaling should happen. So how Prometheus or how KEDA will check that how when this value of threshold is exceeded. So using query parameter here we have given promql query, so that we can determine the value from Prometheus, and that value will be uh, fetched by KEDA, and according to that, KEDA will decide to scale the application accordingly. So this is a simple query where we have just given HTTP request total number of deployment, my deployment within 2 minutes of time. So, and we are using rate function here, which will determine the value of this query, and inside that after that we are just summing up the number and the value here. And the most important thing to make sure that the scalar work properly is query must return a vector or scalar single element response. So this we have to keep in mind because if this will not work, then Prometheus won't be able to transfer the correct value to the KEDA, and KEDA will be confused like how to autoscale the things. So this is a simple code snippet, and this is the example code which we will be also uh, implementing in our demonstration. So you can also check the same in our video as well as in this documentation. So let us not try to waste more time on this page. Let us deep dive deep dive into the demonstration part. So in this video also I will be using playground of Kilocoda, and I will be using Kubernetes version of 1.30, and this is the GitHub repository which I am maintaining for this particular demonstration. I'm using the same repository which I have been using since my past two videos of KEDA, but the branch here is Prom, and inside this I have updated the README as well as the code itself. Okay, so let us try to understand the files which I have written in my repository. So inside install KEDA.shell script, I have just added the CLI commands to install KEDA as well as Prometheus inside my Kubernetes cluster. That's it. So these are just Helm commands. We will be just pasting and running these. And after that, in my deployment.yaml, I have just added deployment and service of my application, which I will be using for my demonstration. These are simple deployment and service manifest file. And the most important file is scaled object YAML. So this is the main file which helps KEDA to determine and decide how to autoscale the application, and it also tells that when to reduce the number of pods or replicas. So let us start with the first line. So API version is keda.sh/v1 alpha1. Kind is scaled object here. Metadata, in metadata I have given the name of demo KEDA scale object. You can give anything. And inside spec scale target reference, I am targeting this deployment name, and these are related to the deployment with like API version and kind. And after that, I'm mentioning that minimum replica count should be one, means one pod of the application should always run, and maximum it can go up to 10 pods. And these are the optional or the default values which KEDA supports. And inside the triggers, which I have already mentioned when we were talking about the documentation, so I have mentioned the same here. And this is a optional field which is ignore null values, which is I have kept true. So default is true, which means ignoring the empty value is from Prometheus. Set to false, the scaler will return error when Prometheus target is lost. So I have used default value of true here. Suppose if after uh, applying PromQL query, and we get some null values here, so we are just ignoring those values here. So this is a simple repository which you can also follow if you're trying to implement the same in your cluster. Okay, so I think let us select our Kubernetes playground here, and let me copy my repository so that I can clone the same in my cluster. Okay, git clone hyphen p-p-r-o-n. I'm sorry, I think I pressed the wrong key. Okay, so repository has been cloned. Let us move inside this folder. Okay, so we can see that. So our first step is to install the KEDA as well as Prometheus inside our cluster. So let me just change the mode of my shell script file, and let us execute the shell script file. So we just have to wait for some time so that it can install KEDA as well as Prometheus. I guess everything is installed. Let us wait for the pods and all other stuff of this repository uh, to get installed correctly and run successfully. Let us check if namespace has been created. Okay, KEDA namespace and monitoring. So in monitoring, I will be storing all the stuff which is related to Prometheus, and inside KEDA, everything which is related to KEDA. Okay. Okay, let me check if everything is up or not inside Prometheus. Oh, in monitoring namespace, I think pods are up, service has been created, pods are also allocated, deployment Prometheus server, I think only this is pending. Let me check for the KEDA as well. Okay, so everything is up. That's good. Okay, so let us let us apply the manifest YAML for our application. Okay, so the service has been created as well as the deployment. So these things are being created inside default namespace. So I don't have to give. Okay, so deployment is up. Oh, pod is up. Okay, let me check the service as well. Okay, yeah, fine. So let me do one thing. Let me put forward my service so that I can execute or just verify that if the pods are able to connect with service or not, and my application is uh, running correctly or not. So this is the service name, and the application is using 3000 port. Let me open a new tab, and let me check if it is returning the value or not, which I have mentioned inside my application. Okay, so yeah, here you can see it's just a simple hello world application, and it's displaying the message as well. So my application is up. Okay, let me also access Prometheus server UI as well. So let me do one thing, get all hyphen n. This I just have to just change the type of this service from cluster IP to node port so that I can have a node port, and we can access the application. So let me edit this kubectl edit svc, the name of the servers and the name of the namespace. Let me do this. Okay, so type here is cluster IP by default. Changing this to node port. Okay, service has been edited. Let us check if port has been allocated or not. Yeah, port is 32061. Let us open this port. Yeah, so this is the homepage of our Prometheus UI, and yeah, so I think let us check if we are able to get some metrics for our application. Execute this. Okay, so here you can see the value of this query. Just a simple the query or the metric, which is returning value 1 because we have tried to access the application once, if you remember, by using curl. So it is using 1 here. Okay, so let us do one thing. Okay, so let me do this one thing. Uh, I have to modify the config map as well for this service. Why I'm doing so, let me tell you that also. Okay, so I've just opened the config map of this service, and in the evaluation interval, I'm just modifying the value of this with 20 second. Let me do 10 second, I think. I'm doing this so because using this, I can easily scrap, or my application will be storing the logs, and I will be able to fetch them within lesser time. So I'm just changing the intervals from 1 minute to 10 second. Let us save this. Okay, so config map is also saved here. So let me check the nodes, the pods of my application. So here you can see one pod is running, and let us apply uh, the scaled object which we have written. So mm, kubectl apply -f scaled object dot yabl. Okay, so this also applied. Let us check by using command kubectl get scaled object. Okay, let me do this. Okay, yeah. So our scaled object YAML file is also been applied, and here you can see minimum board is 1 and max is 10, and trigger is Prometheus. And these are some optional things like active, fallback, and paused. So just as we have not mentioned them inside the YAML, so the default values it's showing is unknown. Okay, and this is the age of the age of this YAML file we have applied. Let us check the pod. So as the minimum pod is 1 here, so it should run the one pod which is already running. kubectl get pods. Okay, so this is running. So what we can do is we can use a utility which will send traffic to our application, web-based traffic, so that and in the parameter we will be passing our HTTP URL, and it will help us to to observe like how KEDA is autoscaling the pods of our application. So let me open one new tab, and in this tab, let me just uh, run this command in watch flag. Okay, so let us move inside this directory, and so the command was okay. Yeah, so the library, the binary is hey. Okay, oh sorry, I forgot that. So let us install hey in our cluster, and here what we will be doing, we will be just passing web traffic using this library. Let me open hey help. Okay, so number of requests to run, which is default is 200 here, and number of requests to run concurrently. Total number of requests cannot be smaller than the concurrency level, default is 50, and this is the rate limit. And you can also check other flag as well, other options. So what I will be needing, I will be using number of requests and number of requests to run concurrently, and here I will be passing the URL of our service. Okay, localhost, and our application is running on port 3000, and inside this let us give value 200 and 200 here as well. Run this. Okay, so from this you can understand that we have sent uh, number of requests to our application in number of 200, means 200 request has been sent to our application. Let us check the same if we can check the value inside our Prometheus uh, tool or not. Let me execute this. Yeah, so here you can see 200, and this is the reason why I edited the config map for our service so that I can get the logs in lesser time. So you can see that it has updated the value of our traffic correctly, and you can see that this traffic is not enough to increase the pod. So let me do one thing. The query which we have written, let me run that, because threshold is 50 here. So let me check this, and let us paste this. Okay, 10 1 minute is more. Okay, so here you can see that it's passing 1.73, which is not uh, enough, and which is not even near to the threshold value which we have mentioned in the manifest file. Yeah, you can see that it's just one. So what we can do is we can send more traffic. We just have to modify the value of the number of requests and concurrent user as well. Let me do this 300 and modify this to 5,000 as well. So from this you can understand that we are just sending 5,000 requests to this service. Okay, let me check. Okay, okay, what, let me do this. Remove these extra parameters. Let us check. Yeah, so here you can see 5001 is there. Okay, so this traffic was enough to trigger Prometheus so that it can auto scale the application. Let me check how many pods has been created by KEDA here. Get pods. So here you can see now two pods are running. Earlier there was only one pod, and now two pods are running. What we can do, let us try to give more traffic. It's fun to me. Let me just give 10,000, and concurrent user, let us give 1,000. Let us check now how the KEDA will work. Okay, so we can also check the real-time traffic to our application from Prometheus point of view as well. Okay, so okay, it's 10. Let me check how many pods are. Okay, so now you can see that now 4 pods of the application is running. So in the watch flag as well, you can see that containers are creating for this application, and 4 pods, four applica of the application is running now. And if we don't provide any more traffic to our application, then using cooldown period, the field of the parameter of KEDA, the application will try to scale in the pods, and it will reduce the number, and it will terminate all the pods, and the application will be back to one pod only, because in the manifest we have mentioned that minimum one pod should be running if no traffic is coming. So for that, I guess the default value is 300 seconds, which is around 5 minutes. So we have to wait till 5 minutes, and then the termination of our pods will start, and then everything will be back to normal. Okay, I think we have to wait a while, and I cannot fast forward the video because I don't know how I can do using the tool I'm using for recording my screen. So please bear with me, or maybe you can skip till the part where the termination will start. So here you can easily see that using Prometheus we have easily autoscale our pods, and setting it up was also smooth. If you will be adding more configuration and more parameters, then you are feel free to add, and it will also refine the scaling decision of KEDA as well. Okay, yeah, I guess we have to wait. So from 4 pods, the application will be back to only one pod. I think we can check the same in our tab 2. Let us check what is happening in tab 1. Okay, so in the tab 1 here you can see that as we have been using Cube Pod Forward for the service we were using, so these are the logs, like how the service was handling the request, and these are the number of this handling connection. It looks good. Let me check again. Okay, still 4 ports are running. I think we can stay in tab 2, where we will be seeing the real-time termination of the pod. I think I should have applied cooldown period. Maybe I forgot to add that in my manifest file. But if you are trying to uh, play around with the same demonstration with the same manifest file, then feel free to add the cooldown period parameter, and you don't have to wait till 5 minutes like we are waiting now. QCT reports. In the Prometheus query, yeah, let me check the query I've written. What is the threshold now? Mm, Let me do this. 5 minutes. So okay, so no traffic was there. 7. Okay, so threshold was 24. So sorry, the value of this query was 24, which is lesser than threshold. So it signifies that so the traffic is not enough to trigger KEDA. Okay, yeah. So here you can see terminating has been started, and let us check. So here you can see that now only one pod is running, which was the initial pod. So here is how you can use Prometheus scaler, which can interact with the HTTP request for which is hitting your application or service, and according to those requests or those metrics, you can use KEDA to autoscale your application in your Kubernetes cluster. So I hope this video was insightful, and this has enhanced some knowledge uh, for you uh, for KEDA as well as Prometheus. So thank you for your time. Have a nice day.